Hi everyone, today I've again brought a question from JEE Advanced 2025. This question is again from electrostatics, and before we describe the question and give the solution, let me quickly explain the concepts which are required to understand the solution. Okay, so imagine you have a isolated neutral conducting sphere. So total charge is 0 and it is isolated. Isolated means this is not connected to anything. Okay, it is isolated. Now you know from conservation of charge that if a system is isolated, the total charge remains conserved. Remember that. Okay. Now here if I bring a point plus q charge, what will happen? This plus q charge will attract the electrons in this conductor this side. So this side will become negatively charged. Now, is it possible that the whole thing is negatively charged? No, because this is isolated. So total charge should be still 0. So if this side is negatively charged, the other side must be positively charged. Okay. And if the negative charge is, let's say, q minus, then the positive charge must be plus q, because total charge has to be 0. The distribution will not be uniform because this plus q is nearer to this side. So the concentration of negative charge here will be more. Now, if I want to know potential of this conductor, electrostatic potential of this conductor, then you know that a conductor is an equipotential surface. Therefore, every point of this conductor must be at same potential. Also, whatever charges are there is outside the conductor. So inside this there are no charges. Even if it was a hollow conductor, inside no charges are present, I have assumed. So since there are no charges inside, the electric field due to charges outside inside the conductor must be 0. This is what is called electrostatic shielding, right? So the total electric field inside the conductor due to charges outside, the total electric field, that must be 0. And if electric field is 0 at every point inside, then potential inside must be constant. This is very, very important. So even if they ask you to find potential at this point, you can say that potential at this point will be same as potential at this point, will be same as potential at this point, will be same as potential at the center also, because inside electric field is 0. That is because inside we have assumed there are no charges, and outside charges cannot create any net electric field inside the conductor. Okay. Now the second thing you should know is, imagine you have a conducting sphere again, and on one side we have negative charge, on one other side we have equal positive charge. Okay, so the total negative charge is minus q on one side, and on the other side it is plus q. Now even if the charges are non-uniformly distributed, so here the negative charge may be more concentrated, here it may be less concentrated, it doesn't matter, as long as you want potential at the center, it will be always be 0 due to these charges. Now why it will be 0? Try to think. If you take one of the minus dq charge here, let's say this is your small negative charge dq, minus dq, then how far that dq is from the center? R, radius of the sphere. So due to this minus dq, the potential here will be what? Minus k dq by r. That is the formula for potential due to a point charge at some point. So this is a point charge, and the distance of the point where I want potential is at a distance r. So this is the formula, right? 1 by 4 pi epsilon naught q by r. That is the formula for potential due to point charge. And I am writing 1 by 4 pi epsilon naught as k. So this is the potential due to this minus dq charge, right? So similarly, if you take potential due to a plus dq charge here, what will be the potential due to this plus dq charge at this point? This is also at a distance r. So it will be k plus dq by r. Now when you find due to all the negative charges, we have to integrate this. And when you want due to all the positive charges, we have to integrate this and then we have to add. So that will be the total potential at the center. Now because r is constant for all the dq's on the surface, so I can take r outside. So it will be minus integral minus dq. Here r is constant, k is constant, take it outside, integral plus dq. And since the total minus dq charge here, whether it is uniformly distributed or non-uniformly distributed, the total negative charge here is minus q. So this will be minus q. And the total positive charge, which is integral of the dq charge here, if you add all the positive dq charges, you will get the total positive charge, which is also q in magnitude. So the total potential must be 0. So the point I am trying to make is whether the charges are uniformly distributed or non-uniformly distributed, if the total charge on the sphere is 0, then potential at the center of a conductor will also be 0. Okay. Now let me describe the question. Now this question has many parts. So there are 4 options and we have to check which options are correct. Multiple options can be correct, remember. Okay. So I will not give the whole question at the same time. I will give it part wise. So the first question says there is a neutral conducting sphere as we have taken in the concept of radius 10 centimeter. A point charge 10 power minus 8 coulomb positive point charge is kept at a distance 20 centimeter from the center. We have to check whether potential of the sphere is 450 volt or not. So basically we have to find potential of the sphere. Now as I told you that the presence of this plus q will induce some minus q charge on one side, and because it is neutral on the other side it will be plus q, right? And I am not showing the distribution because it is not required. Why it is not required is because we know that charges outside will not create any net electric field inside. So net electric field is 0. So potential everywhere in the surface and inside must be constant. So potential here, here, till you reach the surface. Potential everywhere should be same. So instead of choosing these points to find the potential, which will be complicated because we don't know the distances of the charges from this point, we will choose the center point. Okay, so potential of the sphere which they have asked must be same as potential of the center point. Now who will create potential at the center? Obviously it will be potential at the center due to this point charge plus potential at center due to this induced charges which are minus q and plus q. But already we discussed in concept, but since the total charge on the sphere is 0, due to the charges on the sphere, the potential at the center will be 0. So since this part is 0, we need to only calculate potential due to this point charge at the center. That will be k q by r, and q here is 10 power minus 8, and distance of the point charge from the observation point, the point where we want potential, this is given 20 centimeter. So 20 into 10 power minus 2 meter, and k value we know is 9 into 10 power 9, isn't it? And this will make it 20 into 10 power minus 2, that will become, this will become 10 power minus 1, minus 1 will go up, plus 1, that will become 10 power 10, 10 power 10, 10 power minus 8 will be 10 power 2. So 9 by 2 into 100. which will be 4.5 into 100, which will be 450 volt. So the first option is correct, right? Now in the second question they have asked, if the sphere is grounded, okay, if the sphere is grounded, we have to find charge flowing from the sphere to the ground. So how much charge will flow from the sphere to the ground, and they have given it to be this much. So we have to check whether the second part is correct or not. Now once you ground the sphere, now it is no longer isolated, right? So before grounding, the total charge of the sphere was 0, it was neutral. But once you ground, some charge, let us assume, comes from the ground to the sphere. Let us say Q charge came from the ground to the sphere. So Q charge came like this and it stays here on the outer surface. Since you have grounded, potential of this ground is 0 volt, and the moment you connect it to this conductor, potential of the sphere will automatically become same as the ground, which is 0. Now what will be potential of the sphere? We will not calculate on the surface because these charges are still outside, remember, not inside, and therefore electric field inside is 0, potential everywhere is same. So instead of choosing the surface, we will choose the center. So potential of the sphere must be same as potential of the center, which is 0. And who will create potential at the center? This Q and this charge, right? So due to this Q, how much it will be? K Q by distance from the point charge to the observation point, 20 centimeter. If you convert into meter, 10 power minus 2, plus due to this Q charge at the center will be what? K Q by radius. This is radius, remember. Why? Remember, right, when I was discussing the concept, I told you that due to 1 dq, which is a point charge here, if you take 1 dq, potential will be K dq by distance between dq and this point, which is radius of the sphere. Then when you integrate to find the total potential at the center due to all these charges, R is same for all these dq's. That is the main beautiful part, okay? So all these dq's are at same distance from center, so R will come outside. And if you integrate dq, you will get the total charge on the sphere, which is Q. Okay. Now let's calculate this. K value, I can take 9 into 10 power 9 outside. This will be 2 into 10 power minus 1. So 1 by 2 into 10 power minus 1 will go plus 1, 10 power minus 7. Plus, remember, K I took outside, and this Q we don't know. And R is how much? Radius of this is 10 centimeters. So 10 into 10 power minus 2 meter. That should be 0. So this you can divide here, right? Again it will become 0. So then you can take this that side. You will get half into 10 power minus 7 is equals to minus Q by, this will become 10 power minus 1. If you cross multiply, it will become half into 10 power minus 8 with minus sign, and this is 0.5 into 10 power minus 8, which can be written 5 into 10 power minus 9 coulomb. So the charge on the sphere is minus 5 nanocoulomb. So charge on the sphere is minus 5 nanocoulomb. What does this mean? Well, before grounding, what was the charge on the sphere? 0. Because this was plus Q, this was minus Q. Now what is the charge on the sphere after grounding? Minus 5. So if 0 becomes minus 5, if you are neutral and you became minus 5, it means what? You lost plus 5. So plus 5 nanocoulomb must have gone from the sphere to the ground in order for the neutral sphere to become minus 5 nanocoulomb charge. So therefore the answer given here is correct, because the sphere has to lose this much charge to the ground. So if the sphere is grounded, charge flowing from the sphere to the ground is 5 nanocoulomb, which is correct, right? Okay. Now in the third part, they have done some changes, okay? So the grounding is removed. So now this grounding is removed, and the charge plus 10 power minus 8 coulomb, this point charge, is moved by a distance 10 centimeter further from the center of the sphere. So now this charge is moved further 10 centimeter. Okay. So now the charge is here, the point charge, plus 10 power minus 8 coulomb, which means from the center now it will be at what distance? 30 centimeter. So in the third part we have to check the charge on the sphere after we have done all these changes will be minus 5 nanocoulomb or not. We have to check. Well, once you remove the ground, this again became isolated. So whatever charge it acquired from the ground, that will remain as it is. Moving this charge will not change charge on this because there is no connection between this charge and this sphere. There is no conducting path, isn't it? So moving this charge will have no effect on the charge on the sphere, the total charge on the sphere. Therefore, the charge on the sphere will remain minus 5 nanocoulomb because it is now isolated. So third point is correct. Now in the fourth part, we have to find the final potential of the sphere after all these changes are done, which is given to be 300 volt. So now the potential of the sphere will be same as potential at the center, because even now the charges are outside only, right? And due to this charge, let me call this charge q, it will be kq by distance between this q and center, let's say it is small r, plus due to this charge on the sphere, it will be kq by radius of the sphere, which is capital R. And that will be equal to k can be taken outside, q by r plus q by capital R. This is 9 into 10 power 9. Capital Q is 10 power minus 8. Radius is 30 centimeter. So 30 into 10 power minus 2 meter. The charge on this sphere is minus. So we have to write minus 5 nanocoulomb. 5 into 10 power minus 9 divided by the radius of this is 10 centimeter. So 10 into 10 power minus 2. Isn't it? So now this can be written 3 into 10 power minus 1. This can be written 10 power minus 1, right? Then this minus 1 will go up, plus 1. So this will become 10 power minus 7. This minus 1 will go up, it will become 10 power minus 8. And if I take 10 power minus 8 common, here I will get 10 to the power 110 I should get, right? 10 by 3 minus 5. Because this is 10 power minus 7, right? So if I take 10 power minus 8 common, when I multiply this with 10, I should get 10 power minus 7. So this will be 9 into 9 minus 8 here will be 10. This will be 3 here. 10 minus 15. So this will be 30 into minus 5, which is minus 150 volt. But here they gave 300 volt. So fourth option is wrong, right?